I am. Thanks, John. So yeah, just as a quick kind of run through of some of the things to keep in mind that we see customers looking at as they're transitioning their container workloads into Kubernetes. Windows Server 2019 is really the kind of the necessary starting point. Windows containers began back in Windows Server 2016 and the associated semi-annual channel releases around there. However, for Kubernetes, we're talking Windows Server 2019 or newer. And so in Windows, there are two separate release channels. There's the long-term support channel, and there's also the semi-annual channel. Semi-annual is where all of the latest, greatest, brand new features are landing from Microsoft and is really advisable for folks that are working with Kubernetes. However, what we often see in the real world is that customers have a challenge with the semi-annual channel. It only has 18 months of support. It's only licensed through large EA agreements or on the cloud providers. They can be challenging. So we do see a lot of folks that are sticking with the Windows Server 2019 long-term channel, which is perfectly available if you're not needing to be on the very bleeding edge there. The node selector pieces inside of kube manifest become really important really quickly in that this is a piece of the YAML schema for pods that we don't historically necessarily add into our YAML. As soon as you have a mixed cluster where you've got Linux workers and Windows Server workers, becomes apparent very quickly when you have the kube scheduler trying to place Linux pods on top of Windows or vice versa. Because of the way containers work and the fact that we need a Windows kernel somewhere, a Windows pod can only run on top of a Windows Server worker node. And so those node selectors really help the kube scheduler make sure that the Linux pod you're deploying lands on a Linux worker, Windows pod on a Windows worker there. And one other kind of piece there around kind of the different operating system versions. Windows Server is only supported as a worker node right now. There are some other orchestrators in the market where they can run as a master or manager node. For Kubernetes, that's really, you're going to have some level of Linux servers as part of the cluster to be those kube masters that are there. From a privileged container perspective, this is a concept that we have in Linux, in the Linux container world, where a container can have kind of super permissions on the host OS that doesn't exist in Windows Server. And so why we see that come through is for things like the CSI for persistent storage, the container storage interface. That requires privileged containers. And so while CSI in Linux is working and is kind of the way forward with persistent storage, right now with Windows, it's a little complicated. The CSI for Windows is currently in an alpha state. It's coming together, but we're having to work around some of those limitations of not having privileged containers that are there. And so right now, if we're doing persistent storage, which is one of the very first things we see customers hit in the real world when they're doing these workloads, persistent storage is key. We have flex volumes as part of the in-tree plugins available through Kubernetes. So basically, you've got an SMB file share somewhere. We can plumb that into your pods through either iSCSI or flex volume, are kind of the two options today. In the future, we'll be able to move towards CSI for Windows, which should provide a much more modern, robust set of features for persistent storage. So that's definitely one of the first things that we hit. The second one being identity. Typically, if we're going to be running a Windows pod in Kubernetes, this is something where we're probably going to be running a .NET framework application from 3, 5, 15 years ago. We're typically not talking about the brand new .NET Core type applications. .NET Core is cross-platform. And so if I'm a .NET Core developer, chances are I'm going to choose to compile that down into a Linux container and deploy as a Linux pod. They're smaller, there's less resources, they're much easier to use. Whereas if I'm using a Windows pod, it's probably because I have an older .NET Framework app. That's a great pattern. We see folks taking those older applications, containerizing them all the time. But the first thing those applications typically hit is the need for GMSA. So actually, if we can back up a couple to one right there. Yep, we can stop right there. So as far with .NET Framework apps, from an identity perspective, what we often see is that developers for 10, 15 years have been utilizing integrated Windows authentication. Big fancy word. What it meant is that as a developer, I could click a tick box in Visual Studio and voila, I have all my plumbing together for my app with Active Directory to where it would handle all the user auth for me. It was very easy, very simple to use, but it did depend on my virtual machine being plumbed together with Active Directory. We call it domain joining. And so with containers, we don't domain join every single pod that spins up. That would completely overwhelm Active Directory. It was never designed for that kind of cattle kind of mentality. It was much more designed for pets, where we joined a server to AD, sat there for 10 years. So the pattern we use with Kubernetes and with containers in general is that we domain join the host nodes, the worker nodes, to Active Directory. And then when we create a container, with kubectl apply or otherwise, we pass in what we call a credential spec file into the pod. And then that is able to set the identity of that container to our AD identity rather than the default out-of-the-box identity. What that means is that when I'm on the container, I'm going off of the container to talk to a domain secure resource, something like a database, MSMQ, file shares. I will then use that Active Directory identity. And so this is a key piece there around making sure that we've got identity in those containers. So that, just wanted to hammer on those two big points today: persistent storage and identity as the first things we see in the real world as you're moving beyond hello world, as you're moving beyond really the basic IIS app and what we see there. So I'll pause there. Want to make sure we have time here for any kind of questions, concerns, feedback, commentary. Are Windows Pod something that those of you on the call are looking at and evaluating or deploying today?
Hey, this is Hitesh. Can you hear me?
I sure can.
So we are planning to deploy our legacy web services to Windows Container.
Mm-hmm.
We have been exploring that in Azure, trying out. So, and we have a Windows Authentication in place. So I still not clear with what you explained because I'm new to this part. So can you help me understand from that legacy application point of view?
Absolutely. So if I have a legacy app that's utilizing integrated Windows Auth, I can, when I put that into a container, it's not going to run because the container is not domain joined to the domain controller in Active Directory. So I can either A, completely rip out my entire identity system of my legacy app and recode all of that with something more modern, OpenID Connect, SAML2, et cetera, which is expensive, timely, and a pain in the butt. Or I can simply utilize components that are native into Kubernetes with group managed service accounts to be able to do that plumbing for me and not have to change my code base. Essentially, when the application spins up and runs in the container runtime and Kubernetes are wiring up that identity for me to where I don't have to change code there. But it would be a thing where if you're deploying up into Azure, you would likely need a domain controller up in Azure, either running as an IaaS virtual machine with each of your Kubernetes worker nodes domain joined, or with a more the PaaS service, Azure Active Directory Domain Services, which would also provide similar functionality there. But it's essentially, if you take your old app, put it in a container, and just run it, it's going to fail because it can't talk to AD. The app code expects to have Active Directory there.
Right. So there's something in Kubernetes needs to be done to pass through the controls.
Okay. There is, yes. We call it a Group Managed Service Accounts, or GMSA. That is deployed as a CRD, a custom resource definition in Kubernetes, to where it's something you've got to kind of enable and do some minimal setup, just some plumbing work. But once that's set up, and it deploys as a kube secret, you basically can pass that secret in to the container at runtime with that CRD, and it will wire up the connection points there to where your container can still use AD for you.
Wonderful. Thank you.
Of course.
Have a question. Do you hear me fine?
I sure can.
Okay, so we are in the process of migrating an extremely old legacy application that relies heavily on the COM+ applications, or COM+ components, better said. What's the outlook for those? So we haven't really started looking into that, but it's a little bit daunting. Would like to know what's coming ahead.
So off the top of my head, I'm not familiar with the COM+ components inside of Windows containers. That would be something worth trying. It's very rare that we find apps that just simply can't function inside of Windows containers.
Mm-hmm.
But for COM+, that might be more of a question for maybe the Microsoft team that's developing containers there. What I'd say is that if you can get it up and running in a Windows container, utilizing Docker and a container runtime, then we can bring that into Kubernetes. But step one is going to be, from a dev perspective, making sure you've got all the containers created and your Docker files ironed out. Oftentimes, if there are for older applications, you have an option of different base layers for Windows containers. So we have kind of Nano Server is for net new kind of .NET Core apps, very new stuff. For legacy, we're typically talking Windows Server Core or the full Windows base layer. For older applications, we typically suggest starting with Windows Server Core. If there's a component or a piece of the operating system that's not there, then you can always revert back up and try the full Windows base layer. It's very large, but it has much more components of Windows inside of it. And then additionally, if there are additional libraries or frameworks that we need to load in, that's where in our Docker file, we can add those components to copy those in. There are oftentimes still all those libraries and binaries that are sitting today in PowerShell docs or in different file shares. We can collect those, add them into the Docker file, and then be able to encapsulate those additional libraries into the Windows container that's generated from the Docker file. So it kind of depends on your exact use case, but that's kind of the patterns we typically see as far as incorporating various other components into a Windows container.
Okay, thanks.
Hey, this is Hitesh again. Are there still any limitations which I can do in Linux, but I cannot do in Windows in terms of like service mesh and?
Yeah, good question. So those gaps are closing rapidly. I think from where we were with Windows Server 2016 back in the day, we've come a long way with Windows Server 2019, and the Microsoft team has done exceptional work making that closer and closer. So some of the notable differences there, the image, the container image size is much different. Linux can be, 5 or 10 megabytes. Windows containers probably 1, 5, 10 gigabytes. They're much larger. There are some differences. We talked about privileged containers being a different piece there. We talked about some of the storage pieces being a little bit different there. But in general, we're getting closer and closer, and there's not nearly as many differences as there were, say, 3 years ago. So they are different, but Microsoft's working very hard to make sure we can close that gap as soon as possible.
So we can use this in production environment.
Windows containers are good to go for production, both as on the container runtime and in Kubernetes. Windows support came into Kube in Kube 1.14 about a year ago, and so we've had a full year of additions to the ecosystem in addition to Kubernetes, really polishing up that experience and making it better. The first things you're going to hit in production are storage and identity, and hence why I bring it up here. But it is ready for prime time, and you're ready to move those legacy Windows apps into Windows containers, orchestrated with Kubernetes, and be able to take advantage of all of the niceties of Kubernetes as an orchestrator. Yeah, well, I think in general it always raises eyebrows when we hear you're going to run a 10-year-old .NET app in a container, and so this is not a solution for every single app ever created. If you've got a mission-critical monolith that is doing all the payment processing for your business, lifting and shifting that into a container is probably going to be a pain point for you. Where we often see the biggest value prop is a lot of the smaller line of business type applications. So we've got 50, 100, 200 random apps that are used by our employees to do random tasks. They're not mega scale, they're not large. We don't have to do global scale for these, but they are helping calculate the sales tax in Brazil twice a quarter. Very niche kinds of jobs that were created 10 years ago. They still do their job just fine. By moving those into a container, even as a monolithic container, deploying it onto Kubernetes, we get substantially better economies of scale, better density around that because we can retire physical servers and VMs. And then we also get a much better DevOps story that's there. So certainly it would always be better to let's decompose the app, let's move it on to newer languages there. So they say we are better off refactoring. It depends on the application. Again, if for larger, massive scale apps, yes, we'd recommend let's refactor. The other pattern we often see is kind of a crawl, walk, run approach. Hey, we're going to lift and shift into a container today, and then we're going to start taking off pieces of that and decoupling that. So in an ASP.NET app, I may decide I want to spin up an Nginx-based reverse proxy in front of that app. It gives me some caching, doesn't make me have to hit the database every single time. We can put some pieces in front of there. We could implement Redis in between the app and the database as well. There's a variety of other microservice type things we can do around a legacy .NET app that's not going to give us benefits. What we often see is, hey, Stephen, we've got 100 applications. We can't afford, both in time and money, to go burn down all hundreds of those and redevelop them in .NET Core or Golang. There's just not budget for it. But we want to have some benefits operationally of Kubernetes. That's where, okay, let's start moving those into containers, either with no code change or as minimal code change as possible. Typically, we say configuration change because database connection strings are adjusted. But we see immense value and flexibility offered by moving these applications into containers.